the vast stillness of space, where silence drapes everything like a soft invisible blanket, there is a traveller. We call it 3i Atlas. Not a star, not a planet, not even from our solar system, but something stranger, an interstellar object, drifting in from the deep unknown. Right now, this visitor is out of sight. It has slipped behind the blinding light of our sun, shielded from Earth's telescopes. From here, down on our little blue planet, we can't see it. Not with any of our most powerful optical eyes. It's as if it has chosen to hide, just for a while, and we wait. We wait in quiet curiosity, wondering, what is it doing now, behind that glowing curtain of light? What will happen next? Is it intact? Is it unravelling? Or is it changing in some way we cannot yet imagine? Behind the sun, in a region we call the solar blind zone, 3i Atlas continues its silent approach toward a pivotal moment, a kind of celestial test, and we, earthbound observers, are left only with questions. But let's go back a little, back to where we first noticed it, back to when the universe tapped us gently on the shoulder, and we turned to look, pause. It was on July 1st, 2025 that astronomers made the first sighting. Out there, far beyond the orbit of Jupiter, a tiny spark was moving. It wasn't a star, and it didn't belong to our familiar solar family. It was an outsider, a messenger from far away, and it was moving fast. How fast? In just a little over 3 months, it had travelled nearly 700 million kilometres, cutting across the vast gulf from Jupiter's orbit straight toward our Sun. 700 million kilometres. That's the kind of distance we usually struggle to picture, but imagine it this way. Light, which races at unimaginable speed, takes over 30 minutes to cross that distance. And yet this object, this wanderer from another star system, covered it so swiftly that astronomers were stunned. By the time October arrived, 3i Atlas had already vanished behind the Sun. It had reached a part of the sky where no Earth-based telescope could follow. It was there, in the blind spot, where only our imaginations and a few clever space instruments could try to keep watch. But this is not the end of its story. Far from it. You see, October 29th, a quiet date on our calendars, is, for 3i Atlas, a moment of fate. It will mark its perihelion, the point at which it comes closest to the Sun. For a comet, that moment is a reckoning. The sunlight grows searing, the radiation intense, the solar wind unforgiving. Some comets thrive, others don't. And so we wait again, not with fear, but with gentle wonder, in the dance between ice and fire, between distance and closeness, between knowing and not knowing. A tiny, ancient traveller is writing its chapter in the book of the cosmos. The story is unfolding slowly, like a dream drifting through the solar system, and in the next breath we'll follow it closer. Long before it slipped behind the Sun, long before it caught the attention of astronomers. 3i Atlas had already been travelling for an unimaginable stretch of time, perhaps billions of years, not through our solar system but through the quiet darkness between the stars. It came from interstellar space, that wide, vast nowhere that stretches endlessly between star systems, a place so cold, so empty, that light from even the nearest suns fades into soft shadows. And yet, through that darkness, 3i Atlas moved, silently, without a trail, without anyone noticing, until it arrived here. On July the 1st, 2025, telescopes picked up its trace, faint, fast, foreign. It didn't behave like a solar system object. Its trajectory was strange, not bound by the gravity of the Sun, not following any planetary path. It was entering our solar neighbourhood on what's known as a hyperbolic orbit. That means it wasn't coming back. It wasn't looping around the Sun the way a comet like Halley's does. Instead, it was just passing through, like someone stepping briefly into a room, then vanishing again into the night. The last time we saw something like this was with Oumuamua in 2017 and Borisov in 2019. Both were interstellar objects. Both stayed only a short while. But 3i Atlas is different. It's larger, brighter, and moving on a path that has taken it deep into the inner solar system, right toward the Sun itself. From the orbit of Jupiter, 3i Atlas plunged inward, covering that immense stretch of 700 million kilometres in just over 3 months. That speed is hard to feel from Earth, where our lives are ruled by days and months, but in cosmic terms, it was like a whisper, fast, fleeting, and nearly gone before we could even react. The sun's gravity pulled it in, accelerating it steadily, and like a moth drawing close to a flame, 3i Atlas approached the place where many comets meet their end, the perihelion, the closest point to the sun. As of now, it's already hidden from us, shrouded in the glare of the sun. But its journey continues, unseen, uninterrupted. We can no longer watch it with our telescopes, but the cosmos doesn't wait for us. It moves forward, gently, persistently, as it always has. So we look forward now to that moment of reckoning, to October 29th, a day that will decide the comet's fate, and perhaps reveal a few quiet secrets from the distant edges of the galaxy. What might happen on that day? What forces will meet at that point of closeness between fire and ice? We'll explore that very slowly in the next part. Now, in the quiet stillness beyond the reach of our telescopes, 3i Atlas moves closer to the sun, not just in distance but in destiny. There is a day on the calendar that holds particular weight in the life of a comet. For 3i Atlas, that day is October 29th. It is the date of its perihelion, a soft-sounding word for what is in truth a test of survival. It means the point at which the object will come closest to the sun, the moment it enters the most intense heat, the most powerful radiation, a trial by fire. Let's pause on that word, perihelion, from the Greek peri meaning near and helios, the sun. A nearness not of comfort, but of challenge. Because as comets draw closer to our star, the rules begin to change. Ice becomes gas, gas becomes jets. The peaceful stillness of space becomes a place of transformation. The heat at that distance, the raw sunlight, is intense. It penetrates even the oldest, hardest materials. And for a comet, especially one born far from any star, this heat can be both awakening and destructive. At perihelion, the very materials that have preserved the comet's ancient secrets, the frozen ices and trapped gases, may begin to sublimate. That's when a solid turns straight into vapor, no liquid stage in between. It's like watching frost turn into mist under a rising sun. But in the vacuum of space, this process is fierce, sudden, explosive. Some comets endure it, others shatter, and a few simply disappear. And so, as 3i Atlas slips deeper into the sun's domain, scientists are watching, even if they cannot yet see. They are modelling, they are guessing, they are waiting with quiet attention for what the solar wind will reveal. And what comes next is not just one fate, but three possibilities, three different endings, or perhaps three different beginnings, await this traveller from beyond the stars. Each one shaped by what lies deep within it: structure, composition, age, resilience. What will happen when 3i Atlas faces the sun head-on? We'll explore the first possibility next, that it survives and shines even brighter than before. A moment of beauty, if it comes to pass. To understand what might happen to 3i Atlas, we need to understand what a comet truly is. Not just a ball of ice and dust, but something far more fragile and far more telling. A comet is a kind of time capsule, an ancient relic. It is made of material that hasn't changed much since the very beginning of the universe, before planets formed, before stars like our sun ignited. Imagine a snowball, gently packed not by hands but by the quiet forces of interstellar dust and ice. Now add in grains of rock, molecules of gas, and frozen chemicals that might not even exist on Earth. That's a comet. It is soft in some ways, brittle in others, and profoundly old. And now, it is nearing the very heart of our solar system, a place of heat, pressure, and overwhelming light. At perihelion, sunlight hits the comet's surface directly. Temperatures rise quickly, and in response the comet begins to shed. Ice turns to gas. That gas bursts out from beneath the surface, forming jets, streams of material shooting into space like invisible geysers. These jets are not gentle. They carry with them tiny particles of dust, bits of rock, and occasionally fragments of the comet itself. As these particles spread out into space, they catch sunlight, reflecting it, scattering it, and creating the glow we see from Earth. That glowing tail, and the most poetic part of a comet, isn't just light. It's evidence of change, of survival, or sometimes of collapse. Now, for 3I Atlas, astronomers believe one possible future is that it may survive the heat. In fact, it might do more than survive. It might shine. If the core of 3I Atlas is strong, perhaps protected by a crust of rock or even metal, it could endure the rising temperatures of the Sun's proximity. As it does, the frozen carbon dioxide inside it would rapidly sublimate, and this in turn could create directional jets, powerful outflows of gas shooting out into space. Think of them like miniature rocket thrusters, but instead of steering the comet, they illuminate it. These jets fling out particles that reflect more sunlight, and the more particles, the brighter the comet appears. This could cause 3I Atlas's brightness to increase dramatically. Astronomers estimate it could reach magnitude 8, bright enough to be spotted by amateur telescopes on Earth. Even small backyard instruments could catch a glimpse of it. And when that happens, if it happens, what we would see is more than just a glow. We would see the shape of its tail gently trailing behind, curved by the solar wind, fading into the distance like a soft watercolour brushstroke. A reminder of its passage, a signature written in dust and light. And for those watching through the lenses of Earth's observatories, this would be a chance to witness something rare, an interstellar object reacting to a star's heat, up close, something we've never clearly seen before, a moment not of theory, but of truth, carried on a glowing trail through the dark. We'll stay with this hopeful possibility a little longer in the next part, because if 3I Atlas survives, what it shows us could rewrite what we know about these cosmic wanderers. If 3I Atlas survives its close encounter with the Sun, we may be rewarded with a sight of quiet wonder. Imagine early November. The comet begins to emerge from behind the Sun, no longer hidden, but revealed once more to the watchful eyes of Earth. It will appear faint at first, a shimmer in the vastness, but then perhaps it will grow, a glowing point with a soft, elongated tail stretching behind it like a veil of stardust. Astronomers estimate that, if it endures, 3I Atlas may become visible with simple amateur telescopes, not bright enough to dazzle the eye unaided, but just enough to reach us, a whisper of light from another world. And there's something comforting in that, in knowing that, even across this immense emptiness, something from a distant star system can make itself seen, delicately, without violence, without sound. The glow we would see is not just beauty, it's information. The tail, the colour of the light, the shape of the jets, all of it carries clues. That's why, as soon as 3I Atlas re-emerges, instruments across the globe, including powerful space telescopes like the James Webb and ground-based giants like Subaru and Gemini, will point their mirrors toward it. They will measure how its light has changed. Compare its composition before and after perihelion. Track the shifts in its spectrum. This data is more than technical. It helps scientists understand how interstellar material behaves when exposed to intense heat. It reveals how ancient ices release gases, how alien chemistry reacts to a star's radiation, because this is not just a comet, this is a visitor from beyond. Its composition may be unlike anything in our own solar system. It may be made of substances that formed around a different sun, perhaps in a different kind of nebula, at a different point in the universe's long unfolding. And if it survives, if it shines, we'll get a glimpse of that story. Not through words, but through light. This is the first time humanity might observe an interstellar object under such intense solar conditions, and in such detail. And perhaps, just perhaps, hidden in that glow will be some trace of where it came from, or even what came before it. For now, we can only wait and hope. Hope that this fragile traveller endures the fire and returns to us bearing light. In the next part, we'll gently explore just how old this comet might be, and what its incredible age could mean for science and for us. Now let us slow down even more and drift deeper into time. 3I Atlas isn't just distant in space, it's ancient, older than our Sun, older than Earth, older than the planets that circle gently in their orbits today. Astronomers estimate that this object is more than 7 billion years old. Let that number settle in your mind, not as a measurement, but as a feeling. 7 billion years. That's longer than the entire history of life on Earth. It predates the formation of the Moon. It comes from an era when the Milky Way was still young and stars were forming at a faster pace. We do not know what star system gave birth to 3I Atlas. Its path through space is not tied to our own. It likely formed around another star, perhaps long since extinguished, and was cast out by gravitational forces left to wander between the stars, not for years, not for centuries, but for eons, drifting, alone. It may have passed near other systems. It may have crossed vast, empty voids. It may have been frozen solid for most of its existence, locked in perfect stillness, like a tiny sealed envelope from the early universe. And now, for the first time, it approaches a star once again. Our star. The Sun is just one more stop on its eternal journey, perhaps the only star that will ever draw it this close. And as sunlight penetrates its outer shell, as warmth touches the frozen memory stored deep inside it, we may get our first chance to understand what this traveller is made of. Not just ice, not just dust, but the ingredients of early planetary systems, the raw materials from which stars, moons, and maybe even life itself can begin. In a way, comets like 3I Atlas are time machines. They allow us to study what the universe was like long before Earth was born. And though it appears small in our skies, just a point of light, a blur with a tail, and what it represents is vast. It represents the beginning, not of this story, but of all stories. In the next part, we'll explore the second possibility of this comet's fate, that instead of surviving, 3I Atlas might begin to fracture, to crumble, to break apart into many smaller pieces, scattering its ancient secrets across the Sun's domain. Even as we hope for survival, we must gently turn our gaze toward another possibility, a quieter ending, a more fragile fate. Because while 3I Atlas is ancient, it is also delicate. You see, comets, especially those from beyond our solar system, often have a loosely held together structure. Their insides aren't solid like rock, but more like frozen sponges, porous, uneven, held together not by strength, but by stillness. And when that stillness is disturbed, when heat creeps in, when pressure builds, when gases expand faster than the comet can release them, that fragile interior can begin to crack. This brings us to the second path that 3I Atlas might follow: partial disintegration. Not an explosion, not a dramatic shattering, but a slow, creeping fracture that begins beneath the surface and then spreads. Scientists estimate that more than half of all comets that pass close to the Sun experience some form of structural failure. It's not unusual, it's not even violent, at least not in human terms. It happens like this. The comet begins to brighten as its jets activate and its gases release. From a distance, it may even appear more radiant than before. But then, something changes. The brightness plateaus, then fades more quickly than expected. Telescopes watching closely might notice debris trails, or fragments moving on their own paths, separated just slightly from the main body. Sometimes, the nucleus, the core of the comet, splits into 2, 3, or more parts, and each one begins to drift away, tracing its own soft spiral in the sunlight. In the vacuum of space, this doesn't look like shattering glass. It looks like a trail of crumbs stretching across the sky, beautiful but temporary. If this happens to 3I Atlas, its brightness will likely spike for a few days. Then, as the pieces disperse, the light will fade. The comet's path will no longer be a single point, but a cloud, an arc of dust and ice, slowly being scattered by the Sun's gravity and wind. Astronomers can use these changes in brightness, shape, motion, to reconstruct what happened. By studying the timing of the dimming and the distribution of the dust trail, they can model how and when the object fractured. In some cases, if the breakup is mild, the fragments can continue to orbit for a time, their fate still tied to the Sun. But in others, the pieces simply drift apart, each one fading a little more each day until nothing is left to follow. If this is what happens to 3I Atlas, we'll still learn a great deal, because even a quiet crumble can reveal what the inside was made of, how it held together, what gases it stored, how it responded to heat. It will still speak to us, just in a softer voice. In the next part, we'll consider the third and most final of all outcomes. What if 3I Atlas doesn't just fracture, but completely disappears? There is a third path, one that is neither survival nor partial breaking. It is the quietest and perhaps the most profound. It is the possibility that 3i Atlas may not emerge at all, that it may be gone completely. This is what scientists call total disintegration. It happens rarely, perhaps in only 20% of similar cases, but when it does, it leaves almost nothing behind. No glowing tail, no drifting fragments, only dust. And not even much of that. Let's imagine how this might unfold. As 3i Atlas approaches the sun's scorching light, its surface begins to heat up rapidly. The gases trapped inside begin to push outward, trying to escape. But if the comet's structure is too weak, if its body is more like powdered snow than solid ice, then the rising pressure won't just crack it, it will pulverize it. Piece by piece, the object may be torn apart, not in a flash, but in a slow unravelling. From the outside, it might appear as a growing haze, a blur where once there was a point of light, a faint shimmer that then fades. By the time 3i Atlas emerges from behind the sun, if this has happened, we may see nothing. Not a tail, not a glow, not a core, just the faintest wisp of dust spreading thinly into the solar wind. Too dim for most telescopes to register. It will have become one with the solar system, absorbed, erased, and scattered. In a sense, it would have dissolved into light and wind, the final gesture of a billion-year journey. And for those waiting on Earth, this outcome will be quietly sobering. Astronomers may point their instruments toward the coordinates, expecting a signal, a brightness, a return, but instead, they will see emptiness, a blank patch of sky, and in that silence they will still learn. Because the absence of light, the absence of structure, the disappearance itself will be data, a message, one that tells us just how fragile interstellar objects can be, how the journey across galaxies does not always end with light, but sometimes with surrender. It may not be what we hope for, but it is still meaningful, still beautiful in its own quiet way, and it reminds us the universe is not obligated to perform for us. It simply unfolds in ways that we sometimes catch and sometimes miss. In the next part, we'll explore how, even in this blind spot behind the sun, humans have built tools, silent watchers in space, to keep following the comet's path, no matter what happens. Even though 3i Atlas is now hidden behind the brilliant veil of the sun, humanity has not lost sight of it completely. We've prepared for this moment. We've sent quiet observers into space, designed not just to study comets, but to watch the sun itself, from positions we on Earth could never reach. One of these silent observers is SOHO, the Solar and Heliospheric Observatory, a collaboration between NASA and the European Space Agency. SOHO has been watching the sun since 1905, patiently recording its flares, its storms, and yes, the comets that venture too close. SOHO lives in a very special place, a gravitational balance point known as L1 or the Lagrange point between Earth and the Sun. From there, it floats in stable harmony, always facing the sun, never blinking. It can see what Earth cannot. Even when our side of the solar system turns away, SOHO remains aligned, a sentinel in the light. And during this period, while 3i Atlas moves invisibly behind the sun from Earth's view, SOHO can still watch. It can track the motion of the comet as it approaches perihelion, that critical moment of closeness. But SOHO is not alone. Another spacecraft, even closer to the sun, is standing by. Its name is Parker Solar Probe. Unlike SOHO, which watches from afar, Parker dives toward the sun. It has already made multiple orbits, each one swinging closer than the last, skimming the edges of the sun's outer atmosphere, the corona, where no spacecraft had gone before. Parker is protected by a specially designed heat shield, allowing it to withstand temperatures that would melt most instruments. It can survive where comets may not. And during 3i Atlas's closest approach, Parker may be close enough to capture rare up-close observations, images, spectral data, details of the comet's reaction to the sun's heat that no other device can access. Imagine that. A machine built by human hands, dipping through waves of solar fire, quietly recording the fate of an object born long before Earth existed. Instruments like Parker and SOHO give us eyes where we have none. They are the extension of our quiet curiosity, floating calmly in the harshest places imaginable. And thanks to them, even if 3i Atlas disappears from our skies, its journey will not go completely unseen. In the next part, we'll begin to look ahead. to what happens after perihelion if 3I Atlas survives and begins to drift away from the Sun once more. There may be a window of beauty, a final gift, waiting just beyond the light. Let's return to the hopeful path. Let's imagine that 3I Atlas endures. It does not vanish into dust. It does not fracture into drifting fragments. Instead, it survives the close encounter. It passes through perihelion intact. If this happens, a new chapter begins, one that may offer us a rare, beautiful chance to study an interstellar object in detail. Because after perihelion, once the comet swings past the Sun, it will begin to drift outward again. Its path will carry it away from the star's heat, away from the solar corona, and back into the cooler reaches of space. This moment, beginning in December, could be our golden window. During this time, 3I Atlas will still be warm, still glowing, still releasing jets of gas and dust as it gradually cools. But it will also be visible again, no longer lost behind the Sun. Telescopes across the world, from Chile to Hawaii to the Canary Islands, will be able to turn their eyes toward it. And so will space-based instruments. Most importantly, they won't just be watching for light, they'll be listening for chemistry. Because this is the moment when astronomers can begin to analyze the comet's tail, its jets, its emissions, its molecular signature. Using infrared observations, scientists can detect what kinds of gases and ices are escaping. They can look for carbon dioxide, methane, ammonia, even organic compounds, the kind that may once have contributed to the building blocks of life. And this matters, because 3I Atlas is not from here. Its chemistry is not guaranteed to match the comets we know. It may carry molecules that never formed in our own solar nebula, or ratios of common gases that suggest a completely different history of star formation. Each spectrum we capture, each chemical signature we decode, tells us a little more about the star system it once came from, and maybe, just maybe, about how planetary systems elsewhere begin and evolve. It is like decoding a message sent across billions of years, a quiet message, written in vapor and light. In the next part, we'll follow how astronomers track 3I Atlas's path as it leaves the Sun behind, measuring its orbit, studying its trajectory, and confirming that yes, this visitor truly came from the stars. Now that 3I Atlas begins to retreat from the Sun, astronomers shift their gaze from its chemistry to its path. Because part of the mystery of interstellar objects is not just what they're made of, but where they came from and where they're going next. After perihelion, if the comet has survived, its orbit becomes easier to observe. The blinding interference of the Sun fades, and with it, the chance to trace its movement against the dark velvet of space. This is when observatories like the Gemini North and South telescopes step in. They're among the best at detecting orbital motion, tracking tiny shifts in position over days and weeks, measuring the curve of a comet's trajectory with stunning precision. Why is this important? Because by following the arc of 3I Atlas's movement, astronomers can calculate its origin, not just its immediate path, but its journey through the galaxy. They look for hyperbolic motion, an escape trajectory, a curve that doesn't circle back but opens outward. This is what distinguishes interstellar objects from native solar system comets. If the numbers confirm that the path is unbound, that the Sun's gravity cannot pull it back, then we know this is a true interstellar traveller, not a long-lost remnant of our own system, but a foreign guest on a brief visit. This was the case with Oumuamua in 2017 and with Borisov in 2019, and now, perhaps, with 3I Atlas. But there's more. By backtracking its motion, scientists can simulate its possible origin point. They can run models of galactic motion in reverse, seeing where the object might have been millions of years ago. They look for stars it may have passed near, systems it may have once belonged to. Sometimes they find nothing. Sometimes they find a candidate. Either way, the process gives us a sense of scale, a reminder that this tiny glowing object has likely wandered through the galaxy for billions of years, unclaimed, unseen, until now. The study of its orbit also tells us how much it was nudged by the Sun, how its path was altered by radiation, solar wind, and gravitational tides. Every small adjustment is part of the story, the push and pull of stellar physics acting on something older than Earth. And even as 3I Atlas fades into distance, these calculations remain, stored in models, written in numbers, held in quiet observatories for years to come. In the next part, we'll reflect on the brevity of this moment, on how soon this visitor will slip away once again, heading out of the inner solar system and back toward the deep. Even if 3i Atlas survives its passage around the Sun, even if it reveals its chemistry and confirms its interstellar origin, our time with it is still limited. This is the quiet truth of celestial visitors. They do not stay long. For a few short weeks after perihelion, we may have the rare chance to study, to observe, to wonder. But by early 2026, this visitor will begin to fade. It will continue outward, leaving the inner solar system behind. Its tail will shrink. Its brightness will dim. Its jets will quiet as internal ices return to stillness, and though our telescopes will follow it as far as they can, eventually even the most sensitive instruments will lose sight of it. Its trail will vanish into the black, and like a dream half remembered upon waking, we will no longer be able to reach it. This is the nature of interstellar objects. They arrive unannounced, stay only briefly, and vanish. Each one we detect is a rare event, a passing window into matter from other stars, other beginnings. But there is beauty in that brevity. It reminds us how much the universe is in motion, how many paths crisscross this galaxy, how many stories we may only glimpse once. And in that brief moment we can learn more than centuries of guessing, just a few weeks of visibility, a handful of spectral lines. A trail of dust across a sky. That's all we get, but it's enough. Because the presence of 3i Atlas, its brief light, its unique chemistry, its ancient motion, tells us that there are more. That space is not empty. That between the stars, objects wander. Not randomly, but with purpose drawn from the physics of time itself. In the next part, we'll trace the final retreat of 3i Atlas as it accelerates away from the Sun, heading back into the same silence it emerged from. A silence that spans light years. A silence we can no longer follow. As we drift into the final phase of this story, 3i Atlas continues its journey, not toward us, but away. Having passed closest to the Sun, having offered whatever spectacle it could, a brightening glow, a silent disintegration, or simply a whisper of dust, the comet now begins its long arc outward. It will no longer be heated by the Sun's fierce radiance. Its jets will subside, its tail will grow faint, and slowly, inevitably, it will slip from our view. By early 2026, 3i Atlas will be travelling farther and faster, gaining speed as it escapes the gravitational grip of the inner solar system. It won't stop, it won't turn around. Its path, like that of other interstellar objects, is a one-way trajectory, a hyperbolic curve that leads outward, beyond the orbits of Mars, Jupiter, Neptune, beyond the Kuiper belt, beyond the heliosphere, and back into the quiet, cold dark between stars. For us, its retreat marks the end of a rare window. We will lose its light, its data, its presence, and perhaps in the decades to come, our instruments will no longer detect it at all. It will fade from our databases, disappear from our screens, and become, once again, a mystery in the dark. Just as it was before July 1st, 2025, when someone first noticed it near Jupiter's orbit, a subtle flicker in the sky, hiding in plain sight. But the story doesn't truly end here, because 3i Atlas has given us something, a brief encounter with material older than Earth, older than the Sun, perhaps even older than the galaxy as we know it. It gave us a moment of reflection about the nature of cosmic time, the silence of space, the beauty of things that pass by just once. We may never see this comet again. But that's what makes its appearance so meaningful. It reminds us how much of the universe is happening outside our field of view, and how lucky we are, on this small blue planet, to catch a glimpse of something as it passes through. In the next part, we'll step back even further, to consider where this ancient traveller may have begun, and what it carries with it still as it vanishes into the starlit dark. Let's slow our thoughts even more now, and imagine where 3i Atlas began. Not in our solar system, not near any of the planets we know, but somewhere far beyond, perhaps in a place we've never seen, around a star we'll never find. It may have formed in the swirling cloud of dust that once surrounded another star, perhaps one like our Sun, or not like it at all, a red dwarf, a blue giant, or maybe something now long gone, extinguished in the quiet of galactic time. 3i Atlas may have orbited that star once, looping around it as countless other comets do. But at some point, a nearby planet passed too close, or another star drifted by, or a collision sent it tumbling, and it was thrown out, cast into interstellar space, no longer bound by any gravity, no longer held by any light. It became a wanderer, and for billions of years it travelled. Not with purpose, not with direction, but with momentum. A quiet glide through the darkness, passing between stars, between clouds of gas and dust, through arms of the Milky Way. It may have been tugged by distant forces, nudged by galactic tides, its path altered by encounters we'll never trace. And then, somehow, it crossed into the outer edges of our solar system. Unnoticed at first. Just another point of light, until we looked closer, until we realized this object does not belong here. And that's when the story began for us. But not for it. For it, this is just one more sun in a long sequence of stars it has passed near, some too far to warm it, some too dim to be remembered. But our sun has drawn it close, and for this brief moment we get to see it, to ask questions, to listen, to wonder. What might it carry sealed inside its frozen core? Not life, perhaps, but maybe the raw ingredients of life. Carbon molecules, water ice, organic compounds that, given the right conditions, could have played a role in the beginning of something living. Some scientists wonder, are comets like this the seeds of life scattered throughout the galaxy? Could Earth itself have been touched, billions of years ago, by a similar object, one that delivered the spark of chemistry that later became biology? We don't know. But 3i Atlas reminds us that the building blocks are out there, everywhere, carried by quiet visitors who ask for nothing, and leave behind only questions. In the final part, we'll return to Earth for a moment and reflect on what it means to be observers in a universe so full of movement, so full of stories, so full of passing lights. Now, as 3i Atlas fades into the farthest corners of space, we return quietly to where we began. Here on Earth. Still looking up, still listening, still wondering. We won't see it again, not in a lifetime. Not in 100. It is already moving beyond the reach of our instruments, its light becoming fainter than background stars, its presence dissolving into memory. But that doesn't mean it's gone, because what 3i Atlas leaves behind is not just a trail of dust, but a moment of contact. A shared intersection between our world and something far older, far colder, and far more distant than we can ever visit. For a few brief months we stood witness. To a body shaped not by this solar system, but by another, to materials formed under alien conditions, to chemistry written in a different nursery of stars. It came to us by chance, or so it seems. But maybe the universe is full of such meetings, happening all the time, just beyond the edge of what we can see. Think of how many more there must be. Interstellar objects passing through the sun's realm, unnoticed, unlit, unremarked. Some smaller than a car, some larger than cities, some never touched by light at all. We're only just beginning to catch them, to name them, to learn their shapes and colours and speeds, and with each one, we remember something important. We are not alone in the materials of the universe. The elements we find out there, carbon, oxygen, hydrogen, nitrogen, are the same ones we find here, in comets, in oceans, in us. This is not poetry. This is science, measured in spectra, confirmed in data, but felt deeply in moments like these. 3i Atlas may be gone from our skies, but it leaves behind a trail of inspiration, a trail of questions. Where did these objects truly come from? How many more are on their way? And what else might they bring, in their silence, their chemistry, their simple motion through space? We don't need them to stay. It's enough that they pass through, just long enough for us to look up and notice, and with that, we let go. We release 3i Atlas to the long dark ahead, a traveller again, carrying dust and memory into the stars. Sleep well, wanderer, we'll be watching the skies.